Okay, so we know that we need to balance chemical equations because of this law called the conservation of mass or the conservation of matter. And we have to account for all the atoms we start with being there at the end of a reaction as well. We can't have extras, we can't lose any. We have to have the exact number of atoms we started with. And we know that we can calculate the molar mass of each piece, each chemical in a chemical equation. So we're going to put it all together today, and we're going to say, knowing those two things, you should be able to now prove that the law of conservation of mass actually works. So I'm going to show you how to do that. Okay, here's our typical equation. We've seen this example many, many times. This is the formation of water using hydrogen and oxygen. So how do we prove that the law of conservation of mass using a balanced chemical reaction? Well, there's 3 steps in this process, okay? The first step is you have to actually balance your reaction. So as it's written right now, this is not a balanced chemical reaction. We have 2 H's in our reactants, 2 on our products, that's good. 2 oxygens here, but only 1 here, so we better make another copy of this. We're going to say we need 2 of those. Now we have 4 hydrogens and 2 oxygens, so 2 oxygens, 2 oxygens. But we have 4 hydrogens here and 2 over here, so we better double that as well. Now this is the balanced form of this equation. 2 H2s plus an O2 will give us 2 H2Os. All right. First step always in conservation is to balance. And we already knew that to show conservation of matter, you have to balance an equation. That's why we balance. Okay, second step is to determine the molar mass of each compound in that reaction. So I have split our reaction up into 2 colors. Red is our reactants here, and blue is our products. So we're going to break it up, and we're going to find the molar mass of 2H2, and then we're going to find the molar mass of O2, and then separately we'll find the molar mass of 2H2O. Okay, so over here we're going to do our H2s, and I just put some lines here to separate our math. So how many hydrogen do we have? Okay, we have 2 H2s, which means 2 times 2 is 4. So for hydrogen, we have 4 of them. Each one has a mass of 1, which means that the molar mass of 2H2 will be 4 grams. Okay. Next, we can calculate the molar mass of O2. Here you have how many oxygens? 2 would be right. So 2 of them, each one weighing 16 grams per mole, means that this is going to have a mass of 32 grams. Okay? Lastly, we have 2 water molecules, and we want to know how much mass that is going to have. So we're going to break this up. We have our hydrogens. How many hydrogens do we have? 2 times 2 is 4. So you have 4 hydrogens, each one with a mass of 1, 4 grams being contributed to this 2 molecules. And then you also have 2 times 1 for our oxygens. So you have 2 oxygens, each one weighing 16, which is 32. So the total mass of 2 water molecules is 36 grams. Okay, so that's step 2. You determine the molar mass of each piece in that equation. Okay. Lastly, step 3. We need to add up the mass of the reactants and then you add up the mass of the products and show that they're equal. Okay, so here for our reactants, we have 2 reactants. We have H2 and O2. And we have their masses already figured out. So all we need to do is take the mass of this reactant and the mass of this reactant and add them together. When we add them together, we get 36 grams. And we don't have any adding to do for our products because we only have 1 product. A lot of times you will have 2 products or even more, and so you would need to add together their masses just like we did for our reactants. But for this example, we only have 1 reactant, so no adding is needed. But notice, the total mass, the mass of our 2H2 and the mass of our O2 is 36 grams total. And the mass of our product is also 36 grams. So you can see here that the mass of the reactants we started with is equal to the mass of the products. And as you work your way through these problems, you should at the end get 2 matching numbers. Circle them, show that they're equal, and you're golden for showing that this law holds true. That's it. That's the whole 3 steps, okay? Hopefully you wrote down the example in your notes. You also have a practice one for Fe plus H2O. Gives you Fe3O4 and H2. Try that one on your own. Have Miss Bankston check it over before you do the rest of your practice problems on the next page in your notebook. If you have any questions, let me know.